Okay, class, now that we have a basic understanding of what a mole is and how to use it, let's dive into some practice problems so you can get more of a feel of these kind of calculations. This video is going to be broken down into two types of problems. The first type of problem I'm going to show you is the mass to mole problems, while the second type of problem is going to be atoms to moles problems. I'm going to try to incorporate chapters into this video, so if you feel more comfortable with one type of problem, you can go ahead and skip it to another type of problem easily. For my students who are using this video to review for the AP exam, remember, being able to convert a substance to moles or out of moles may be only one step in the question you may be solving. More than likely, it is going to provide you the information you need to ascertain what you need to answer the question. Okay, so without further ado, let's get into these problems. Mass to mole problems will either give you the mass of a substance and you're going to convert to moles of that substance, or vice versa. Here's a basic framework for solving these types of problems. Mass to moles equals the given mass of a substance over 1 multiplied by 1 mole of this substance over the atomic mass of that substance. This will ultimately have us divide the given mass by the atomic mass to get moles of a substance. If we're going to go from moles and we want to go to mass, we simply put the moles of our substance over 1 and multiply the atomic mass of the substance over 1 mole of that substance. This will result in a simple multiplication problem of the number of moles of substance multiplied by the atomic mass of the substance. Now let's try to work a few problems. Our first one is going to say, how many moles are in 150 grams of magnesium chloride? When working these problems, first we need to understand magnesium chloride's formula. Magnesium chloride's formula is MgCl2. Now we can set up our problem. We have 150 grams of MgCl2 over 1, and we multiply that by 1 mole of MgCl2 over X grams of MgCl2. This X grams is going to be the added up atomic mass of this compound. So before we can go any further, we need to find the atomic mass of this compound. So if we set up our atomic mass table, we have 1 magnesium atom and its atomic mass is 24 atomic mass units. So we're going to write 24 down. Then we have 2 chlorine atoms, each at 35 atomic mass units. So then 35 times 2 is 70. Now we just sum up our 24 and our 70 and we get 94 atomic mass units. Now we can take that 94 atomic mass units and put that into our formula. So now we, instead of having 1 mole of magnesium chloride over X grams of magnesium chloride, we're going to have 1 mole of magnesium chloride over 94 grams of magnesium chloride. Once we multiply our tops out and bottoms out and then divide our top by our bottom, we get our answer of 1.6 moles of magnesium chloride. Now for our second question. How many moles of arsenic do I have if I have 300 grams of arsenic? Okay, so my first step is going to put 300 grams of arsenic over 1, and then I'm going to multiply it by 1 mole of arsenic over X grams of arsenic. This X grams is my atomic mass. I go look at my periodic table and I see arsenic's atomic mass is close to 75 atomic mass units. So I'm going to put, instead of X grams of arsenic, I'm going to put 75 grams of arsenic. Now, basically, this turns into a multiplication and division problem. And so I take 300 times 1 and 75 times 1, and I get 300 over 75, which equals 4 moles of arsenic. Now for our third one. If I can isolate 5 moles of potassium from a solution of potassium chloride, then how many grams of potassium did I isolate? So I have 5 moles of potassium over 1. Then I'm going to multiply that by X grams of potassium over 1 mole of potassium. That X grams is our atomic mass. If I go look at the periodic table, that's 39 atomic mass units, so it's going to be 39 grams of potassium over 1 mole of potassium. So now it's just basically multiplying 5 by 39, and I get 195 grams of potassium. Okay, our final one for the mass mole problems is, while doing a lab, you are directed to measure out 1.35 moles of iron. Using only a scale that measures out the mass of a substance, How do you know if that you correctly measured out 1.35 moles of iron? So basically what we're going to be doing in this question is figuring out what mass do I need to have on that scale to equal 1.35 moles of that iron. So I'm going to put 1.35 moles of iron over 1. Then I'm going to multiply it by X grams of iron, which is the atomic mass of iron, over 1 mole of iron, so 56 grams of iron over 1 mole. This turns into a multiplication problem of 1.35 times 56, which gives us 75.6 grams of iron. How do I know that if I have 1.35 moles of iron? Well, if I measure out 75.6 grams of iron on my scale, then I have 1.35 moles of iron. Now let's work a few of the second type of problems, atoms to mole problems. Like you can conclude from the name, atoms to mole problems will give you atoms of a substance and ask you to calculate the moles of a substance, or vice versa. Here's the model for solving these types of problems. In order to go from atoms to moles, we are going to put our given amount of atoms of our substance over 1, then multiply it by 1 mole over Avogadro's number, which is 6.022 times 10 to the 23rd atoms of that substance. This will have us divide our known amount of atoms by Avogadro's number to get the desired amount of moles. If I'm given moles and want to find the number of atoms present within a substance, then I'm going to do this. Take my given moles from a substance and put them over 1. Then I'm going to multiply it by the relationship of 6.022 times 10 to the 23rd atoms of that substance over 1 mole of that substance. Okay, so now here's a few practice problems. A computer chip contains 1.2 times 10 to the 23rd atoms of silicon. How many moles of silicon are in this computer chip? Well, the first thing we're going to do is put our known over 1, or 1.2 times 10 to the 23rd atoms of silicon over 1. Then we're going to multiply it by 1 mole of silicon over Avogadro's number, or 6.022 times 10 to the 23rd atoms of silicon. This results in a division problem of 1.2 times 10 to the 23rd divided by 6.022 times 10 to the 23rd, and we get 0.199 moles of silicon in this computer chip. Next problem is we have 3.011 times 10 to the 24th atoms of calcium oxide, and we want to figure out how many moles of it there is. So first thing we're going to do, we're going to put our 3.011 times 10 to the 24th molecules of calcium oxide over 1. And then we are going to multiply it by 1 mole of calcium oxide over 6.022 times 10 to the 23rd molecules of calcium oxide. Again, this results in a division problem of 3.011 times 10 to the 24th over 6.022 times 10 to the 23rd, which results in 5 moles of calcium oxide. Our third problem is a piece of copper wire contains 3 moles of copper within it. How many atoms of copper are within this wire? So I'm going to take my 3 moles of copper and put it over 1. Then I am going to multiply it by 6.022 times 10 to the 23rd atoms of copper over 1 mole of copper. This basically turns into a straight multiplication of 3 times 6.022 times 10 to the 23rd, which gives us 1.807 times 10 to the 24th atoms of copper are within this wire. Okay, our final question for the day. If an alloy contains 2.47 moles of aluminum, then how many atoms of aluminum does this alloy contain? Okay, same thing as our last one. We're going to take 2.47 moles of aluminum over 1. Then we're going to multiply it by Avogadro's number over 1 mole. So 6.022 times 10 to the 23rd atoms of aluminum over 1 mole of aluminum. And so we get, when we multiply 2.47 times 6.022 times 10 to the 23rd, we get 1.487 times 10 to the 24th atoms of aluminum produced. Okay, now that we have finished up these practice problems, you should have a better understanding on how we can use moles to convert between units. Remember, sometimes with these problems, using the mole conversion may only be one step in solving a bigger picture. Whether it is a complicated problem or just a straight plug-and-play problem, being able to convert substances to and from moles is a huge part of chemistry. Finally, keep up the good work in class, and see you next time.